Do, doing good. How are you?
I'm doing fine. Thank you for asking. So we have another online class today. And I heard Wednesday tomorrow there'll be another snowstorm. So if that really happens, most likely Thursday we'll have another online class. If tomorrow snows. But if tomorrow is a normal weather, even if it's less snow, then we will have in-person class Thursday. Hmm. So any question? Comments, concern, anything before we start?
Do you know when we're getting our test back?
Uh, I'm done grading them. My plan was to give them back to you today, but since I couldn't, so I'll give them back to you Thursday
Okay.
if we have in-person class. But
With
I
these,
say our test grade wasn't so good. Half of the class failed. So I'm kind of sad about the test grade, kind of disappointed, kind of sorry. I'll let you know. You're great. Any other question?
with
I was
the
wondering, I'm sorry, I have a question. I was wondering why our tutors couldn't keep the exam because we were trying to um study it on Friday class, but we couldn't do it.
Friday class. But the Friday was after the exam. There was no class.
With our tutors, with our PLT leaders,
Oh, why you couldn't do that?
because they didn't have the exam.
The review sheet?
No, they didn't
yeah,
have.
we just wanted to go over the test with
Yeah.
the PLTL, but she didn't have hers because she took it away.
Yeah, that's true. And I didn't because there was someone was going to take it later. That's why. But my plan for next class is actually it was my plan, but then I changed my plan. Um, my plan was give you test back on testing and then go over that. But then someone suggested, well, instead of going over that, maybe you should find your own mistake and then figure out why you made those mistakes. And then we can discuss that together. And you get some points for doing that. So I'll think about it. 5.1, I did not upload yet. Uh, I'll upload after class. Okay, Kelly? So today we will start chapter 5, even though my plan was to do 4.5, but 4.5 is word problems. So I realized if I teach you word problems here, most likely you won't be able to understand much, but those word problems are final exam questions, so you definitely need to know them better. So that's why I'm skipping 4.5 for now and then leaving it to for our next class, for our next in-person class. And today my plan is to start 5.1 and we will be finishing 5.1. So next week, Tuesday, you have your homework 5.1 and 4.5. I remember I put 4.5 deadline 28, if I'm not wrong. Because I didn't want you to have many homework on next Tuesday. But since I'm not going over 4.5 today, so I will put the deadline for 4.5 on February 3rd instead of 28. Okay, any other question?
I have a question.
Go ahead, Taz.
You
Taz.
said that you approved the deadline for which chapter instead of February
4.5 will
28th?
be next week, Tuesday,
Next week, Tuesday.
and
What week is
5.1.
that? Sorry, you said
4.5 and
4.5?
5.1.
Oh, 5.1.
Mhm.
Okay.
So our initial test was 100, right? And we had to get 60 to pass.
No, initial test was 75.
And we had to
So,
get a
and then I
60.
convert that into 100% skill. So after converting into 100% skill, if you get 60, you pass.
Oh, okay.
Mhm. And even if you don't get 50, 60, like not you individually, like student, if your student don't get 60 in one of the tests, it's fine as long as you have higher score in the other exam. That will average up your low score. Okay, so 5.1 is an interesting section, kind of fun, kind of scary. It's fun because all you have to do is apply exponent rules, and it's scary because you have to remember the exponent rules. So we are talking about exponents here. We already know what exponent is. Exponent is a superscript, and it tells us how many times we have to multiply the base. So when you have a number raised to the some power or some number or some variable or anything, that superscript has three names. One is power, one is index, one is exponent. And whatever we have on the bottom, we call it base because base is supposed to be on the bottom. So bottom is base and power is exponent, index, or power, superscript. So if you have 6 cubed, it means multiply 6 3 times. So any power tells us how many times we have to multiply our base. Only multiply, not divide. Power always tells us to multiply. And sometimes we multiply, sometimes we, depending on what we have, sometimes we have to use pandas. So pandas, if you have no idea what that is, it means you have some exponent, not exponent, order of operation. And thus P means parentheses, E means exponent, M means multiplication, D means division, A is addition, S is subtraction. So between multiplication and division, whichever comes first, we have to apply that. Between addition and subtraction, whichever comes first, we have to apply that. And then if you have parentheses, that can be simplified. So you have to simplify the parentheses first. And if you have exponents, then you have to do the exponent first. Means apply your exponent to the base, simplify that. So let's start with some easy examples. First one says 4 to the 1. It means multiply 4 only once. So when you multiply 4 only once, you're doing nothing. You simply have your number 4. The next one says 3 square, means multiply 3 twice. So 3 times 3, that gives us 9. Simple. But the next one, we have two things. One is exponent and one is multiplication. So since Pamda says do the exponent first, so we are going to do exponent first. We are going to keep our 3 times, and 2 to the 4 means multiply 2 4 times. As a result, you get 3 times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 4 is 16. And then we do the multiplication. 3 times 16. If you have no idea about that, you do manual multiplication. You get 3 times 6, 18. So 8 goes on the bottom, 1 goes on the top as an addition. And then you do 3 times 1, which is 3, plus that 1, that gives you 4. So 3 times 16 is 48. And you're going to see 3 times 16 a lot in this class. Any questions so far? Okay. Then we have next concept, the base with a negative sign. When you have a parenthesis, everything inside the parenthesis is a base. But when you don't have a parenthesis, that means whatever you have next to that It's a multiplication. Just like on the left page, we have 3 times 2 to the 4. So 3 is multiplying to the base 2 to the 4. Same thing, if you have a negative sign and no parentheses, means a multiplication. However, if you have a parenthesis, it means the entire thing inside the parentheses is base. So applying these rules, 4 square means you have 4 times 4, no sign, nothing. So we have positive 16. But on B, we have a negative and then 4 square. So basically it means negative times 4 square. And now we know 4 square means 4 times 4. So we get negative 16. But in C, we have entire negative 4 on the base. How do you know? Because of the parentheses. The parentheses is telling us our base here is negative 4. So power 2 is telling us, hey, multiply negative 4 twice. So negative 4 times negative 4. And we get positive 16. So see the difference between B and C. B did not have a parenthesis, so it got the result negative 16. But C have a parenthesis on the base, so that's why when you multiply negative 4, you get positive 16. So parenthesis does make a difference. That's why anytime you have a parenthesis, you have to repeat the entire thing inside the parenthesis power many times. Like here, I repeated negative 4 twice because our power is 2. Okay? Any question? Then let's do some example. Volunteer for easy D. Who would like to try D? D.
12.
12. Okay, how did you do that?
2 times 2. It's
So
4 and
2
4
times
times.
2 is 4. And then you did 3 times 4, 12. Good job. Who would like to try E?
Negative 12,
How do you know it's negative 12?
because negative 2 to the exponent of 2, that would be negative 4. So 3 times negative 4 would be negative 12.
So this negative is a multiplication. And 2 square is 4. So 3 times negative 4 is negative 12. Now for the last one. I would like to try the last one. Volunteer. Sorry, it's my niece and nephews. They're always screaming at home.
12. Positive.
How do you know it's 12? What did you do?
So the base is negative, so both of that would be positive, and 3 times
So
4.
negative 2 times negative 2. This gives us positive 4. And we have 12. Good job. So say negative without parentheses means your answer has to be negative. Negative within the parentheses means the answer is positive. Now we are going to evaluate the exponent. Anytime we evaluate the exponent, all you have to do is replace a variable with whatever number they give you. And you have to remember one thing always. Anytime you replace anything with anything, any variable with a number or any number with a variable or anything with anything, always use parentheses to replace. Always. For example, they gave us 3x to the 4 and they want us to replace x with 2. So we are going to replace this x with 2. So we are going to put a parenthesis and then power 4. Since we are replacing x with 2, so this x turn into 2. So 3x to the 4 turn into 3, parenthesis 2 to the 4. And then we know parenthesis is base is 2, power is 4, means multiply 2 4 times. So 2, 2, 2, 2. We get 3 times 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And we did that before. We just did it 3 times 16. So we know the answer is 48. So anytime you replace anything, make sure to use parentheses. Because if you don't, then you will end up making mistakes. Taj.
So, do you put a 2 there just like to substitute for any number?
No, because they're telling us substitute x with 2.
Oh, I see it. I'm sorry. Okay.
Okay, now it's your turn. We have 6 divided by x squared. They are asking substitute your x with -4 this time. So this x on the denominator turns into -4. So what do you do? Pat, did you raise your hand again?
I'm sorry, what'd you say?
Did you raise your hand again, or it was from
Oh,
the
no, let me lower my hand. Sorry.
Would you like to try this one?
Um,
All you
no.
have to do is replace
No.
the parentheses. So we have 6, right? Dasha, go ahead. I saw you hand now.
Yeah, I was going to say that you could put the x variable into -4, but you have to put the parentheses in it.
Good. -4 with the parentheses and then the power 2. If you don't put the parentheses, you'll get another question, another number. If you do put parentheses, you'll get the correct number. So we have 6, and since -4 square, what is -4 square? -4 square means -4 times -4. And what do you get from there? Positive 16 or -16? Which one?
Positive.
Positive 16. But if you don't put parentheses, you're going to get -16, which is wrong. That's why you always have to put parentheses anytime you replace or substitute anything. But both of them are even numbers. So can you reduce them by anything? 6 and 16, they both are reducible by what? Any even numbers are divisible by what?
By 2.
By 2. So we must divide them by 2. We get 4/8. Come on, why 4? 3/8. 3/8. So evaluating an expression means replace your variable with the given number, but make sure to use parentheses. And then apply the rules, exponent rules, simplify. So any questions so far? All these examples are easy, right? Not too bad. Now let's start. Not start, okay, we have one more question. So try that question. Nayari, would you like to help me with this one? How did you come up with your answer?
So can you hear me fine?
Yep.
So I just replaced it really, so I did 5 in parentheses, -1 times -1.
-1 square gives you -1 times -1.
Yeah,
And then y cubed means what?
-2 times -2 times -2.
-2 cubed means -2 times -2 times -2. So what do you get from -1 square?
Just 1.
1. And -2 times -2 times -2?
That's -8.
-8. So what do you have?
And 5 times -8, that's, oh, I mean -40, not 40. Sorry.
-40. Perfect. And that's all you have to do. Substitute and then simplify. Any question on this question, guys? No question. Okay, now comes the scary part. You have to remember some exponent rules. So, good news, you don't have to memorize them as long as you know how to derive them. So before I give you exponent rules, I'm going to help you derive them. So let me skip these 2 pages and let's derive our exponent rules together. The first rule says we have one base but multiple powers. So a to the m multiplied a to the m raised to the power m. So let's see how can we find the rule. Let's start with an example. Suppose we have 2 square to the power 4. It means we have 2 square 4 times. 2 square, 2 square, 2 square, 2 square. Because our base is 2 square, so we multiply our same base 4 times. But now if you look at the inside individually, this is telling us multiply 2 twice. So 2 times 2. The next one is doing the same thing, telling us multiply 2 twice. So let's multiply all these 2 twice. And now let's see how many 2's we have all together. 1, 2, 3, 4, 5, 6, 7, 8. We have 2 8 times. So what do you think? If we have 2 square to the power 4, it turns into 2 to the power 8. So what exactly we did with the powers?
What do you mean? Wait, what
We
do you mean? What do you
added
do
them.
with the power? Oh, add that.
If
Yes.
you add them, you get 2 plus 4, which is 6. But how many we have?
8.
So what did you do? Did you add them?
No, I just evaluated it how you wrote it out. 2 times 2 times 2 times
Just
2
gotta
times 2 times 2
multiply it.
times 2 times 2. You just gotta multiply. So like 2 times 2 is 4. Then you would have 4, so you do 4 times 2, which is 8. You have 8, so you do 8 times 2,
Yeah, but we're not
16.
finding we're not evaluating the base. We are trying to see how many times we have base, we have multiple powers. So multiple powers. Let's start with another example. Let's say we have 3 first 4 times, and then we have this, let's say 2 times. Now let's say we have 3 times. What does that mean? It means they are telling us, hey, write 3 to the 4 3 times. So 3 to the 4, 3 to the 4, 3 to the 4. Now each 3 to the 4 is telling us write 3 4 times. So 1, 2, 3, 4, 1, 2, 3, 4. Now if we write 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, Now total, how many 3's we have? 4, 8, and then 12. We have 12 of them. So my question is, what do
Oh,
we do with these
multiply the
two powers?
exponents.
Multiply them. So
I
that's the
wasn't
rule.
understanding the question. I'm sorry.
It's okay, we are learning. So when we have multiple powers, you're going to multiply them. Okay? So same base, only one base, but multiple powers means multiplication. You multiply your powers. So here we have two powers, m and n. So our rule is keep your base a and multiply the power m with the power n. So multiple powers means multiply the powers. Okay? So if you forget this rule during the exam or anytime, just derive like I did. Work with numbers and figure out how many times you have at the end when you have multiple powers. The next one is saying we have more elements on the base, but only one power. So let's derive our rule. 2x to the power 4 means multiply 2x 4 times. And now observe how many 2's we have. 1, 2, 3, 4. So we have 2 4 times. And we have 1, 2, 3, 4, x 4 times. So what's the rule? When we have more element on the base but only one power, how do we work with the power? What do we do? What do we do? We distribute the power. So 2x, we have 2x to the power 4 that turn into 2 to the 4 times x to the 4. So in other words, we simply distributed the power to every element inside on the base. So next rule says we have multiplication on the base and we have one power. The rule is distribute the power. A to the n times b to the n. So instead of just giving you all the rules, I want you to learn how to derive them because obviously you're going to forget them. We are human beings. You always keep forgetting things. So anytime you forget, instead of making up your own rules, just derive them. Find out what do we end up getting from what is given to us. The next rule is division rule. So let's do the same thing what we did for multiplication. Our base here is 2/3. The power 4 is telling us write 2/3 4 times. So multiply 2/3 4 times. 2/3 times 2/3 times 2/3 times 2/3. So how many 2's we have at the end on the top? 1, 2, 3, 4. And how many 3's we have on the bottom? 1, 2, 3, 4. So if you look at this and compare with that, what exactly we did with the power? We simply distributed the power. 2/3 to the power 4 means 2 to the 4 divided by 3 to the 4. So in general, it doesn't matter what you have. Anything you have on the, any division we have on the base, and you have only a single power, distribute the power to both numerator and denominator. So a to the n divided by c to the n. This is our next rule. That means if you have, let's say, 4xyz divided by 5abc, and let's say whole thing to the power 6. Can you guess what do you get from here? Who would like to try this? 4xyz divided by 5abc. Taj, go ahead.
Okay, so being that we have to, is that distribute?
Yep,
So it'd be, is that a 6? So it'd be 4 to the 6,
4 to the 6.
x to the 6, y to the 6, z to the 6 over s to the 6, a to the 6,
Sorry, this
b
is
to the
my
6.
5.
Oh, 5. 5 to the 6th power, a to the 6, b to the 6, c to the 6.
Mm-hmm. See?
Yeah.
Simple. We're not doing any math here. We're just applying the power, applying the rule. Oh man. Something happened to the living room. Okay, so that was our next rule. And now we have multiplication in the base. So let's see what do you get this time. It says multiply 2 cube with the 2 to the 4. So 2 cube is telling us to multiply 2 3 times. 2, 2, 2. 2 to the 4 is telling us to multiply 2 4 times. 2, 2, 2, 2. So how many 2's we have? 3 and 4. So we get 7 of them. So what did you do this time? Did you add the powers, subtract the powers, multiply the powers, divide the powers?
Multiply.
If you multiply the powers, then you get 2 times 3, which is supposed to be 12. So 3 times 4 supposed to be 12. You add them. So when you have same base, as long as you have same base and they have their individual power, you need to add them. So keep the base ones, but add your powers. So that is our next rule. Same base multiple times means add all the powers. So let's do one example. Let's say we have 2x 3 and 2x, let's say 7. So what will be the answer for this time? 2x cubed times 2x to the 7. Or let's say 2x to the 5. 2x to the 5 times 2x to the 7. What do you think the answer is? Anyone? It's simple. We have the same base 2x. So keep your 2x in your base. And we have multiple powers. Add them. So we get 12. But then we can do more. Why? Because we have another rule that says if you have more elements on the base with one power, distribute them. So we get 2 to the 12, x to the 12, and this is our final answer. This is our one exponent rule, and this is our second exponent rule. So bottom line, it doesn't matter what you have on your base, as long as all the bases are same, you add their powers. And then if you can simplify more, go ahead, simplify more. If you cannot, like this one, just leave it alone. I mean, we can, but just leave it alone. And now our last rule is division rule. So we have 2 cubed divided by 2 to the 4. And the other one says 2 to the 4 divided by 2 cubed. So they look same, but they are not same. They are not same because in one of them, our denominator is bigger. In other one, our numerator is bigger. So let's see what happens when you have this individual scenario. So let's derive them. 2 cubed means 2 times 2 times 2. 2 to the 4 means multiply 2 4 times. And then what happens? Top 2, bottom 2 cancel, top 2, bottom 2 cancel, top 2, bottom 2 cancel. We left with only 2 on the denominator. Since there is nothing left, we have a 1 on the numerator. So when the denominator is bigger, we end up getting a fraction. Now let's see what happens when the numerator is bigger. 2 to the 4 means 2 times 2 times 2 times 2 4 times. 2 cubed means 2 times 2 times 2 3 times. We do the same thing. We cancel out every 2's we have, numerator and denominator. And this time we left with 2 on the numerator. So what does it mean? It means when we have bigger number on the numerator, you end up getting a whole number. So bigger number on the denominator means it's a fraction. Bigger number on the numerator means the answer is a whole number. So for division, there are 2 scenarios. Either your answer will be a whole number or your answer will be a fraction. So 2 scenarios. Either it's a fraction, which is 1 over a to the m minus n. Sorry, n minus, so let me do this way. A to the m minus n. If your numerator is bigger, you're going to get a whole number. Or it will be 1 over a to the denominator minus numerator if the denominator is bigger. So whole number if numerator is bigger. Fraction if denominator is bigger. 2 scenarios. Okay. What is this? It's a yellow bar. No. Green bar. Any question?
No questions.
Then let's do some example. Volunteer for the first one. 7 to the 4 whole thing raised to the power 5.
Can I do it?
Go ahead, Christian.
It would just be 7 to the 20th power.
Good job. 7 to the 20. So we multiply multiple powers. Multiple powers means multiply. Next one, more elements on the base. What do you do? Volunteer for question number 2. Okay, then let me pick.
We're gonna do, I'm sorry.
Go ahead, Sheikh. Go ahead.
I'm going to say we're gonna do 8 to the 9 and x to the 9.
Perfect. So more elements on the base with 1 power, just distribute the power. And you get x to the 9 times 8 to the 9. Same rule with the division. More elements on the base as a division. Who would like to try the next one?
Would it be 2 to the 8th over 3 to the 8th?
2 to the 8 over 3 to the 8. So whether you have multiplication or division doesn't matter. If you have one base, just distribute. Because you are fair. You want everything on the base to have the same power. Same amount of power. Okay, now same base multiple times. Same base you are multiplying. Who would like to try this one? Multiplying same base.
You just add the exponents, correct?
Add the exponents. So we have 5 to
5
the
to the
power
15th.
7, 8, 5 to the 15. Right. Now we have a division. 2 divisions. Volunteer for the first division. Let me pick Italy's.
I'm not sure how to.
No problem. We'll do it together. In division, we have to subtract the powers. That's the rule. Division, the division has a subtraction sign. So division means subtract. Now, which one is bigger, the numerator or the denominator?
The denominator.
That means your answer will be on the denominator. So we are going to keep whatever we have on the denominator and subtract the power from the numerator. So what do you get on the denominator?
2.
2. 9 with the 2 power. Then what goes on the numerator?
The 6.
Nope.
1.
1.
1. If you ever get confused, you can always try this way if the numbers are smaller. So 9 to the 6 means multiply 9 6 times. 1, 2, 3, 4, 5, 6. And then 9 to the 8 means multiply 9 8 times. 1, 2, 3, 4, 5, 6, 7, 8. All these things you're multiplying. Now we can always cancel anything from the top and bottom as long as we are multiplying them. So we cancel 9 of them, sorry, 6 of them. So we have 1 on the top and 9 square on the bottom. In other words, we have 1 over 81. So if you don't know the rule, don't be afraid, just derive them. Okay, the last one. Who would like to try the last one?
Would it be 9? It would just be 9 over 2.
9 over 2 or 9 to the power 2?
I mean 9 to the power of 2, sorry.
Good. We have 9 to the 8, so we keep our 9 to the 8 on the numerator and we subtract the denominator power. So we get 9 to the power 2, which is whole number 81. And again, if you don't know, is it 81 is a whole number or fraction? No problem, derive. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them on the 8 of them on the top, and then 6 of them on the bottom. And then cancel whatever you can. And you see, we're left with 9 squared on the numerator. So if the powers are smaller, you can always derive them. But if the powers are bigger, like 60 or 600, you cannot derive them. So that's why you have to know your rules. Or at least know how to derive them so you can work with smaller numbers. Any question? Kelly,
So would 9 squared or 81, either one of those answered would be right on the test, or we need to write both of them?
if the numbers are smaller, you should always simplify. But if the numbers are bigger, like 5 to the 15, that's a huge number. So you cannot figure out 5 to the 15 without using calculator, leave it. But you know what is 9 square. So try to, anytime you can do anything with your brain, go ahead, simplify that. Any other question from anyone?
I have a question.
Go ahead, Joshua.
What if the base isn't the same? Then what?
We do have base same.
No, I'm saying like what if the base isn't the same?
What if the base
Like
is
for number
not
four, for number
same?
four, for number four.
What if the base is not same, right?
Yeah.
Then you cannot use these rules.
Oh, it's not for the rule? Okay.
So these rules are only for same base. So if you have, let's example, if you have x squared, y cubed, can you combine them? We cannot,
No.
right? Because x and y are not same. So all these rules, they are only for the same base. But good question. Okay, now these are new types of rules. We are going to do them together. So copy this down, and then let me take the attendance, and then we are going to derive all these rules together. So I'm going to take the attendance now. Let me know if you are here. Today is 2/24. Andrea,
Here.
Shake, are you still there?
I'm sorry, I'm here.
Okay. Christian, are you still there?
Yeah, I'm here.
Christina, Christopher,
Here.
Danielle,
Here.
Devlat, no Devlat. Dennis, are you still there?
Here.
Okay. Idalis, are you still there?
Here.
Jared, are you there, Jared? I'm marking you absent. J Luis,
Here.
Joshua, are you still there?
I'm here. I'm here.
Justin,
Here.
Caitlin,
Here.
Kelly, are you still there?
Here, I'm still here.
Okay. Kyle,
Here.
Lady, are you still there? Lady,
Me? Yeah, I'm here,
yeah.
lady.
Muntaha,
Here.
Nayari, are you still there?
Yeah, I'm here.
Nicholas I,
Here.
Nicholas S,
Here.
RST,
Here.
Rana,
Here.
Ricardo,
Here.
Taj, are you still there?
Yes, I'm here.
Mora
Yes, I'm here.
and Zichi. Zichi. No. So absent is Zichi, Jared, and Devlat. Devlat Takiro. No. Okay. Okay, Janavi. Thank you. Okay, lady. No problem. Okay, let's derive this together. The first rule says a to the power 0, where a could be anything that is not 0. For example, 2 to the 0, x to the 0, 2x to the 0. Anything that is not 0. Any idea what the answer is? No idea? The answer is 1. Anything that is not 0 raised to the power 0 is always 1. So 2 to the 0 is 1. X to the 0 is 1. 2x whole thing to the power 0 is 1. Anything, as long as it's not 0, if you raise to the power 0, the answer is 1. That led us to the question, well, what happens when you have 0 to the power 0? Then what? Well, mathematicians have no solid answer for that. Some people say it's 0, some people say it's 1. So what's the result? We don't know. DNA. We assume it does not exist. That's why we have 0 rules separate. 0 to the 0, we have no idea, it doesn't exist. Besides 0, as long as your base is, besides 0, anything on the base with the power 0 is 1. And then we have the most generous number 1. 1 to the, let's say, 0, 1 to the -2, 1 to the +3, 1 to the, let's say, 1/2, or 1 to the decimal, 0.539, anything. 1 with any power, positive, negative, 0, fraction, decimal, anything. Who can guess the answer? The hint is here. What is 1 cube? 1 times 1 times 1. What do you have? 1 times 1 times 1 is?
1.
1. How about 1 square? What is 1 times 1?
1.
1. So 1 to the anything is 1. That's why 1 is the most generous number. It doesn't matter what you throw to it. It's always stays same. It never changes. And then we have our base -1. 3 scenarios for -1. If your -1 has odd power, for example, -1 to the 1, -1 to the power 3, -1 to the power 5, or -1 to the fraction power 1/3, -1 to the fraction power 1/5. Anything that is odd, if you put it as a power on -1, do you know what the answer is? Any guess? What is -1 to the power 1?
1.
-1 to the power 1.
Oh, to the power 1. Oh, that's a -1.
-1. So -1 with any odd power is always -1. Then we have even numbers. For even numbers, there are 2 scenarios. Either the even number we have, they are whole numbers, or they are fractions. Depending on what you have, there are two different types of scenarios. If we have even whole numbers, like -1 square or -1, oh man, I hate this when it happens. See. -1 square or -1 to the 4 or -1 to the 8 or -1 to the 10, -1 to the any whole number power. Sorry, any whole number even power. Can you guess the answer?
It's gonna be +1.
+1. Good job. We have -1 even number, let's say 2. -1 square means -1 times -1. It turns into +1. Same thing, -1 to the 4 turns into +1. -1 to the 100 turns into +1. -1 to the million turns into +1. As long as your power is an even number, -1 becomes +1. And then we have fraction problem. If you have even fraction, for example, -1 to the 1/2. 1/2 power means it's the square root of -1. What is square root of -1? Anybody knows what is square root of -1?
That would be 1.
So square root of -1, it means they're asking what number when you multiply twice, the answer is -1. This is what square root of -1 means. What number square is -1?
Oh no, it's I. It's I.
It's
Is it
I, it's
not?
imaginary. It doesn't exist in real life. So when you have a negative base with an even fraction, it doesn't exist. How could you forget this? We did this in the domain section before the exam. So far we have two DNA. One is 0 to the power 0, and the other one is -1 to the even fraction power. Now we have 0 base. So you already know 0 to the power 0 doesn't exist. And then you have two scenarios. Either 0 have a negative power. It could be negative whole number, negative fraction, negative decimal, negative anything. As long as power is the negative, the answer is it doesn't exist. 0 cannot have any 0 power or negative power. It's undefined. On the other hand, if you have a positive answer, any positive number, 1, 2, 3, 4, 0.1, 0.5, 0.75, or anything positive with the 0, the answer is 0. So 0 is the most sensitive number. It can only have a positive number. If you don't have a positive number, if you have a negative number or 0 power, it doesn't exist. So most strict number is 0. The most generous number is 1. And -1 is in the middle. If you give a fraction, it gives you one result. If you give the even number, it gives you another result. So yep, you have to write all these rules down in one page. So far today, I think we learned about 13 rules. Please have them on one piece of paper. And anytime you do any type of question with exponent rules, have it available in front of you so that you can see all the rules while you do your work. And if you keep looking at all those rules every day, they'll get stuck in your brain and you're never going to forget them. Okay, any question, comments? Nothing? Now let's do some examples. Volunteer for the first one. 1/2 raised to the power 0. So it's the rule number 1. Anything that is not 0 to the power 0. Any non-zero base to the power 0. What's the answer?
1.
1.
1. Good job. How about -4 to the power 0? -4 is our base, and we have power 0.
-1.
Rule
Or
number
1.
1. Rule number 1. It says anything, as long as it's not 0, the power is what? The answer is what? +1, not -1.
Positive, yeah.
So this A, anything, positive, negative, fraction, whole number, decimal, anything, as long as it's not 0, the answer will always be 1, always. So what do you think, guys? The next one, xy to the power 0. Any non-zero thing to the power 0 is what?
Will it be also 1?
Also 1. D, division, x by z. X divided by z to the power, x divided by z to the power 0. What's the answer? Still 1. It doesn't matter what we have inside on the base. Any base that is not 0 and our power is 0, the answer is always 1. The next one, we have two scenarios. One is exponent and one is multiplication. So who would like to try E, the last one? Any volunteer?
Is it -1?
Yeah, it would just be no, it would just be -9.
-9. So -9, and then x to the 0 is 1. So -9 times 1 is -9. So guess what? In the next exam, I'm going to give you all these rules like this type of example. So I'm not going to ask for what's the rule. I'm going to ask for examples. If I give you this example, what's the answer applying the rules? So you're going to have around 35 questions on these exponent rules. These plus you're going to learn more. So once you have all the rules together, and we're done with 10.2 with chapter 5, we are going to have our next exam. I think so. So make sure you write down all these rules and make sure you have them in your brain. Not only on piece of paper, but also in your brain. Now, applying these rules, we are going to do a few examples. So here we have many things together, many rules we are applying together. Who would like to try the first rule? What do you think the first rule here should be? Which rule we should apply here first? We learned around 13 rules so far. So what is our step 1 here? Any idea from anyone?
Distribute the 4.
Good job. Distribute the 4. So we have 3 to the power 4. Then distribute to the next one. We have y to the 5. Distribute the power 4. Then go to the denominator. We have -2. Distribute the power 4. Then we have x cubed. Distribute the power 4. So rule number 1 here we apply is distribution. And then we have 3 4 times. So 3 times 3 times 3 times 3. On the denominator we have -2 4 times. So -2 times -2. And now comes our second rule. Which rule we are going to apply here? One base multiple powers. What do you do? One base multiple powers. What the rule says? Christian?
Wait, I'm sorry. Can you repeat the question? I was talking to my mom.
How do we apply which
Oh, you multiply 5 times 4,
multiply 5
and
times
then you get y to
and
the
also
20th,
for 3 to
and
the
then you would do the
4.
same for x. Yeah, 3 to the 4, 3
So
times
y
4.
to the 20, x to the 12. And now what do you get if you multiply 3 4 times? 3 times 3 is 9.
Yeah, and then 9 times 3 is 27, and then 27 times 3 is
27 times 3.
81.
7 times 3 is 121. 1 goes on the bottom, 2 goes on the top as an addition. 3 times 2 is 6, plus 2 is 8. So we have 81
Yeah, 81.
y to the 20. And how about the denominator?
You would get positive 4 and x to the 12th.
Perfect. And now between 81 and 4, we cannot reduce them by any number. So we stop, and this is our final answer. See? We can apply so many rules together. And one of these will be in the final exam. We are going to apply several rules to simplify an expression. Then we have only 3 more questions, and then we'll go today. So who would like to try this easy one? P to the 5, Q to the 6, divided by P square, Q to the 8. Volunteer for this one? Come on, guys. If you don't know, it's fine. I will help you.
So we would subtract the exponents of p, so we would get p to the 3rd, correct?
P to the 3rd.
Yeah. Then we would subtract 6, q6 minus q8, so we would get p negative to the second, q negative to the 2nd.
But we cannot have any negative exponents.
Oh, you can't?
You have to subtract 8, q8 minus 6.
Good.
Wait, so, okay.
8 is bigger, so keep your 8 on the position for the 8. So instead of writing the answer directly, let's do this. 5 is bigger, so keep your 5, subtract the 2 from the denominator. For Q, 8 is bigger on the denominator, so keep it. And then subtract the 6 from the numerator. We cannot have any negative answer at the end. So you have to convert them into positive anyway. So we have P, 3 of them on the numerator, and Q, 2 of them on the denominator. My 3 looks so weird. So P cube over Q square. And again, since these are smaller numbers, so you don't have to struggle with the rules. You can simply do the math. Write P 5 times. So 1, 2, 3, 4, 5. And write Q 6 times. 1, 2, 3, 4, 5, 6. On the denominator, that's telling us to write P 2 times and Q 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. And now cancel out whatever we can cancel. We have P cancel out. 1, 2, 3, 4, 5, 6. 6Q cancel out. And then you see what is left. On the top, we left with 3p, and on the bottom, we left with 2q's. So p cubed and q squared. Same as this one. See, if you don't know the rule, it's fine. The next one is same. You're going to use multiplication rule to combine the powers. So we have x only alone. It doesn't have any friends. So we keep x to the 5. Then we have y's twice. One is y to the 7. The other one is y squared. And then we have z twice. One is z to the 7. The other one is z to the 3. So in other words, we have x 5 times, y 7 times, and then 2 times. So we have total 9 times. Z we have first 7 times and then 3 times. So we have total 10 times. So these are final answer. X to the 5, y to the 9, and z to the 10. And if you don't want to use the rule, but your powers are smaller, no problem. You can always write this down as they're given. Y 7 times, so 3, 4, 5, 6, 7, and then z 7 times, 1, 2, 3, 4, 5, 6, 7, and then x 5 times. So let me just skip x5. Y 2 times, and then z 3 times. And then when you see all of them, we have x 5 times, y, here we have 7, and here we have 2 more. So we have y 9 times. Z, we have 7 here, 3 here, so we have 10 times. You can use this method when you have smaller powers, but when you have bigger powers like 70, 500, then you cannot do that. So that's why it's better to learn the rules than just use this method. Now the last question for 5.1 is asking for finding the area of the rectangle. So that means we need to know our background knowledge. Who knows what's the area of a rectangle? How do you find area of any rectangle? What's the formula for the area?
Length times width.
Length times width. So they're telling us one side is 7x cubed. Let's suppose this is L. And another side is 9x to the 6. Let's suppose this is W. So length times width means 7x cubed feet times 9x to the 6 feet. So when you multiply, we multiply 9 with the 7, we get 63. We multiply x cubed and x3. So we have x 3 times and then 6 times. So we have total 9 times. And then we have feet times feet. So we have feet twice. In other words, our final answer is 63 x to the 9 square feet. That's why every area problem or every area in real life has a square unit, because we have to multiply the 2 units, 2 sides, to get the result for the area. So your homework for next Tuesday. Homework for March 2nd, I think. March 2nd or 3. Let me see. March 3. So 3-3. Homework for 3-3 is section 4.5 with quiz and 5.1. 5.1, you didn't have to take the quiz because this 5.1 is connected with 10.2. So take the quiz on 10.2 and 5.1 later. But for now, Just do the homework for 5.1 and 4.5. Okay. Any question before you leave?
I think I
Jake.
see on the yes, it's basic. I think I see on the syllabus that if you don't pass the final, you're gonna fail the class.
Are you talking to me? Your voice is so low, I can't hear anything.
Oh, you cannot hear me, sir. Can you hear me?
Yes, I can hear you now.
So I see. I saw on the syllabus says that if you do not pass the final, you're gonna fail the class.
Right. That's a departmental policy, not my policy.
All right, I got you. So what if you fail exams and pass the final?
Then I'm going to calculate your average, class average. And if the class average is below 60, you fail. If it's
Or
above
if that,
60, you pass.
all right, thank you so much.
Mm-hmm. So class average includes your 5 in-class exams, your MyMathLab homework, MyMathLab quiz, and your attendance. I'm going to
All
count
right, thank you.
all the things. And then if that average is above 60, you pass.
All right, thank you.
Mm-hmm. Any other question from anyone? No? Then have a good day. Have a safe day. Don't
Have a good one.
And keep an eye on your announcement. If we have online class next Thursday, I'll let you know on Wednesday. So bye everyone. Be safe. See you on Thursday.